Okay, so it's 9:15, so maybe we start because we have again plenty of stuff that we want to go through. Um, as a first, we had a question on the screen in the our polling system. So, if you had any problems with the exercise one, or if you installed possibly the Python stuff to your own computer, for example, using Anaconda. There was a question already, what is Anaconda? So there is materials in the course website about how you can actually install the stuff to your own computer. So there we describe a bit. So there we have some information about what Anaconda is, but basically it's a software, Python software with a lot of packages installed into that kind of distribution package, and it's kind of easy way to install Python related stuff on your own computer. Let's see if we can get this here. Is it laptop one?
Yeah, do it kind of quick.
Yeah.
And then do the same for the other screen. So, can you hear that? Yeah. Yeah, just one other thing about Anaconda is if you were wanting to use Jupyter Lab on your own computer and do the exercises without using the CSC or Binder, that's the easiest way to do it. You can install Jupyter Lab several different ways, but Anaconda kind of gives you everything all at once in one big Python package with most of the other libraries and things that you would want to use anyway. So it's quick and easy.
Yeah.
But it's not necessary to use unless you want to do the stuff on your own computer.
Yeah, and indeed, so there is information on the website in here. So installing Python. So basically, here is instructions for Windows and also other operating systems. And if you have university computer, so I'm not if you're aware of that there's this kind of software portal. So Anaconda can actually be installed also from there. So it is maintained by the university IT department. So it's kind of a good way to download and install stuff from there. So, but that's maybe about it. Let's just quickly check if there was any other questions related to this one. Can I somehow? No. Now this gets a bit tricky. Maybe I. Like this. Somehow the internet seems to be a bit slow today. But anyway, maybe once
If there's anything else I can tell you.
that comes to my screen.
Yeah, that's the only thing is the what is Anaconda.
Yeah, okay, so there was no further questions. If you still have some questions, you can post them to Slack channels, for example, and we can basically answer there. But let's continue on the stuff for this week. So here again on the lesson overview, you can get a picture of what kind of things we should go through this week and what the learning goals for this week is or are. And basically for this week, we are basically showing you how to use version control, where first of all, what is version control and how you can use Git to communicate and interact with GitHub, which was the place where we can store our exercises and so on. And also that is the place where we actually maintain our website. So that is a good thing to know what that is. And then we will have a Python lesson again, and we go through some basic elements of Python, such as what are lists. So those are the topics for this week. And basically, after this week, you should be able to use our course environment, be able to use Git to actually clone repositories, commit your changes and so on. These words might sound weird for you if you haven't used Git or GitHub before, but you will soon find out what they are. And then you should be able to understand a little bit about Python lists and the data types that we went through already last week. And again, we will put lecture videos after this week, this lesson. So these are from last year, but we will update them to the new ones later this week, probably tomorrow or on Friday. Good. But okay, so are there any questions at this point? If not, let's go to introduction to version control and GitHub. How many of you are familiar with version control before? 1, 2. Okay, so some of you. The ones who are familiar with version control, this might be kind of nothing new for you, but for most of you who haven't ever heard of version control, this is probably very useful. At least it has been for me, and I'm sure for Dave as well. And this is basically how software development and well, most of the programming stuff is done. So we use version control for multiple different purposes. And this nice cartoon maybe explains a bit, at least the problems that I used to have when I was, well, writing my master's thesis back in the day. So I don't know if any one of you kind of are familiar with this situation, that you have kind of written a document, for example, your final thesis, master thesis or bachelor's thesis, and then you kind of might have your supervisor where you kind of send it over. He or she might give you some feedback, and quite soon you might end up having a situation that you have like really long, because you get always a new version of the document with the new comments, and then you modify and send it again. So you might end up having something really awful in the file names, and it's really hard to actually keep track of what were changes, and did I now already include all the changes from the last version and so on. So it can be actually quite nasty situation that you might end up in the end. So what version control does, this is one of the things, but it basically saves you from this mess. So what version control is good at is that basically it can track and store changes in your files without losing the history of any of the past changes. So basically what version control fundamentally does is that instead of kind of taking new versions of the same file, you are actually all the time writing on the same file and committing changes. So this is basically an illustration how version control works. So this is the kind of base or initial document that you might have, for example, some text that you have been written, and then you add a new line. And basically it will show the whole document for you, but it has tracked the change. And then again, you might write some other pieces of text in the document, and you will add that to the same exact file. And then you are always seeing the same file. But what Git and version control does is that it keeps track of those changes that you have been doing. And it can be useful for many purposes. One of the obvious one is that there might be some, well, especially when doing programming, there might be situations that you have been reading a lot of code, then at some point you are writing some pieces of code that is messing up the whole thing, and suddenly nothing works. So if you have this version control and you are actually committing your changes regularly and keeping track of the changes, you can actually go back in time to a place or to a point of time where everything was still working, and you can basically kind of start over from that point again. So that is can be really useful, and there are every now and then situations where, for example, I need to do that, as things might get messy. So it's good to have this option for you. Do you have something?
So yeah, one thing just to add to this a little bit is it might seem like at this point you've written 1 or 2 lines of Python code. Why would you even need to worry about keeping track of the changes, because it's such a simple thing? But you'll see pretty rapidly that we go from dealing with single lines of code to dealing with pieces of code that could be 50 or even 100 lines long. And as you start making changes there, especially if you're doing them kind of late at night, trying to rush to get the exercise done or something like that, being able to go back and see the working version of your earlier form of the exercise will be something that will save you quite a bit of time. And learning this now and kind of getting this built into your normal way of operating, that when you write any kind of little Python code that you're doing it with version control, will save you time down the road. There's no question about that. But yeah, it might seem like a little bit abstract right now. We'll get into using it, and hopefully things get a little more clear, and you'll get practice with it in the exercise for this week too.
Yeah, and during this course you will get plenty of exercise of using version control, because all the exercises that you are doing are basically distributed using kind of version control based system, and you are kind of making your or uploading your like work what you have been doing using version control. So there is no kind of way out of this, so you just need to do it, and that's kind of part of the course and how we planned it. So one of the most popular version control systems, so there are different ones, but we are using Git, which is probably one of the most popular ones at the moment. Maybe, I don't know which one is the most popular, but it is really popular. And that's kind of, it relates somehow to Finland as well, as it was actually first developed by Linus Torvalds, who is actually from our university, and I guess all of you might know who Linus Torvalds is. He's basically the kind of developer of Linux operating system, the kernel of it. So he's pretty famous guy, and he was from the computer science department from our university. So then, why to use it? So we already mentioned a few things that can be useful. So it's possible to go back in time, but another really useful feature of using Git and version control is, for example, how we, Dave, me, Vuokko, and other teachers of the course are all the time working, producing actually these course materials, is that we do things together. And that is something where version control really kind of rules, is that it allows and makes it really easy for many people to collaborate and kind of put own stuff into the common repository and common good, which is in our case is now this course materials that we have here. So it kind of makes it easy, and we can basically, it solves many different things for us. Like there might be changes that Dave did, which I hadn't in my current repository, but then basically I can just pull those changes and so on, and get the same stage as Dave has, and other way around. But we will basically go through a bit more detail in these. There are some basic vocabulary of version control that will become kind of familiar to you. One of them is repository, and basically the exercise 1 that you did on GitHub. So I hope all of you already have GitHub account, and you have done the exercise 1. There was plenty of comments on the Slack channel, so I assume that most of you have done it. But basically the exercise 1 that you cloned on GitHub, that's a repository. And when you take that into your own computer, basically what repository is, it's a folder on your computer with this specific Git related files that actually keeps track of the things that happens on that directory. So it's nothing magical, it's just a kind of folder with files that you put there, and a system that keeps track of the changes that happens inside that folder. So that's a repository, nothing magical. A commit is basically when you do changes to your file and you have decided that, okay, at this point of time, I feel like I should now upload my changes to the internet, for example, to GitHub, so that I don't lose these changes, or it feels that they are kind of that kind of set of changes that makes a good commit. So it's a snapshot of your repository that you push to for example GitHub, which is a remote hub for GitHub repositories. So commit is something that you do really often. A version is basically, well, it's a version of any change made in there. What you are also doing a lot is cloning. So if you have a repository on the web, it can be our exercise repositories, for example, for the exercise 2. So when you are kind of taking a copy of that repository from GitHub or from any place, you are cloning that. So when you are copying the full history and all the changes that have been done to that repository, you are doing cloning. So it's basically copying a full thing, a full repository. Pulling and pushing is something that you will do often. So cloning is when you take the whole repository once from the remote, like GitHub, for example, and take it to your own computer or wherever you are doing the work. Pulling and pushing is such that when you have done a change and you want other people, for example Dave, to see those changes that I have done in some repository that we are commonly working on. So when I push those changes, Dave is able to see those from his computer if he pulls those changes from that remote. So that remote computer is kind of a common node where we work commonly, and we kind of push changes there and pull changes if either one of us has done those things. And a merge is basically when two set of changes, so if Dave makes changes and I do changes, so then those changes need to be merged together so that they are kind of a good piece of code and everything goes smoothly in there. Good, so there was a lot of new words for many of you. Don't worry, they will become familiar to you once we go through. The GitHub is something that you already have seen, and it's basically a place that we use and a website that we use a lot during the course. It basically already the name says a lot that it relies on Git. So it's basically a website that it's a common place to store repositories using Git version control, and that's basically what it is. But it's also a social collaborative network, so that is also something that these websites such as GitHub and GitLab does, is that they are designed for collaboration. So when we are working together, in addition to sharing files and working on some common repository, we can also communicate, raise issues that, okay, there is a problem here, could you, Dave, take a look at it, and so on. So there are plenty of things that can be done in GitHub, for example. So it is really useful website and service that you will learn a bit to use during the course. As we are also trying to teach you kind of open science principles, so GitHub is one of those places where most of the scientific work is uploaded and maintained and kept. So it is kind of GitHub has promoted a lot of open science practices in the field in terms of kind of being a common place where people share their code for other researchers or anyone who is interested about the things that we do in terms of programming. And documentation is also good thing to understand. So on GitHub you can basically create your own websites, such as the course site that we have here, but also any kind of static website. So it's not possible to do any kind of interactive, for example, map services or things like that. But if you have a kind of static website where you don't need to do changes interactively by the user, GitHub is a really good place for that. Yeah, and then well, issue tracking is good. So basically I also already mentioned about this, but if you see a kind of bug or a mistake in somewhere, for example in our course materials, there is possibility that you actually can say that there is a problem here to the developers of that piece of software. And this issue tracking is basically for that. So you can report that I have found this problem, and basically you can notify the developers that please take a look at this. I'm working on this operating system and this doesn't work. What is the issue here? So it's kind of again collaborative and crowdsourced in a way that all the users together are actually contributing to the pieces of software that can be found, or any documentation or whatever you have there. So that's a really quick overview of what Git is, but basically you will understand it much better when we actually start using it, and let's start doing that right now. So in the course, so the basic idea, as I have mentioned already a few times, is that we are always having a remote repository, which is basically held in GitHub. And this can be exercise repository that we share with you. It can be, you can also create your own repositories if you feel like. And it is basically securely stored in the cloud in GitHub. And that is also one good thing, that if I now, for example, work on this computer, make some changes, then I go to another computer. So if I store my stuff on the cloud in GitHub, it doesn't really matter on which computer I work on. So it's really easy for me to just pull the changes that I made from this computer, or push the changes that I made with this computer, go to my desktop computer in my office, pull those ones and continue there. So it kind of makes it quite flexible to work with multiple computers. So remote repository is basically the permanent place where we store things. Then we have a working directory that is basically the local copy of the repository on our own computer. And this is the typical process of how you interact with version control, is that you probably create some kind of new files in your working directory that you have, for example, cloned or just initialized yourself. Then the typical process is that if you make a change to a file, or if you create a new file, the first thing that you do is that you add those files into the staging area, which is basically a place where you kind of choose the files and the modifications that you have done to the commit that you are doing. So this is kind of I don't know, when you choose some ingredients of food, for example, to your plate, and then you put it in the microwave. I don't know. really bad example, but anyway, so you kind of pick the changes and pick the files that you want to commit and make that permanent change to the history of the repository.
Yeah. Maybe one thing to add here is, like, at this stage you haven't actually tracked any changes. You're just sort of telling Git which files you're going to add when you do track the changes.
Exactly. Yeah, so that's a good point. So actually the staging area doesn't yet do any tracking of the history. It's only this git commit phase where you actually set that take the snapshot of the history of the repository. But again, seeing this like in live makes things easier to understand. On the website we have basically few of the common comments that we use. So we have git clone, git add, which is basically putting those files to the staging area. Git status is something useful, and so on. We will soon see these in action so you can understand them better. There is a good link. There's this Git cheat sheet. So on the website, if you open this file, you will have this kind of thing that basically lists all the common commands related to Git. This is basically provided by GitHub. So this can be really useful as a cheat sheet for you to kind of remember things. We have also like real copies of these. Of course, we didn't remember to take them now, but we will share them during the practical sessions tomorrow and on Friday, so you can take them if you wish. Good. But let's start using the Git so that we can actually see what I'm talking about here. So if you can just follow, or then you can kind of do what I do, in a sense that you try to actually do the same things. But basic idea is that we want to launch Pioneer. I have it on here already. So this is basically the same thing. I close this one. So this is the same thing that opens from launching this binder from here. And the idea now is that I will clone the exercise 1 repository that I didn't do it, but let's assume that I have done something there. And then I start working and doing some changes to that GitHub repository. And then Dave will also do some changes there, so we can actually show you how the things typically work. So it's nothing that difficult, but there are few steps that you need to understand and repeat and do those time after time, so then these things will get familiar to you, and it's really straightforward actually to work with version control, but you just need to know few things. So let's clone a repository from GitHub. So basically the typical working steps are that you have some kind of repository on GitHub, such as there's exercise 2, there's here is my, you don't see all these repositories, but we see as we are the teachers, but I will clone my own exercise 1 repository. So basically, whenever you are clicking on the website, that GitHub Classroom, what it does is that it basically takes a copy of our exercise 1 repository that we have created and takes it to your own personal GitHub account. So you can do changes and you can see whatever has happened in that repository, and we teachers as well, but no one else from the group can see those. And you can do anything you like basically with the repository that you have cloned, so you have full access to do any changes there. For example, of course, we expect that you do the exercises that we have written for you there. But yes, so typical thing when you work with version control is that you want to clone a repository. So this can be any repository that you find in GitHub, but I will now clone this one. And in GitHub there is this button, clone or download here, and there is a link that I can copy using this button in here. So if I just click that one, it copies that address to my computer, or to the yeah. And then now I have this Jupyter Lab open. So what I want to do is that I want to take that repository and clone it to here. So clone it to this remote computer that I have opened in here. And how do I do that? So the easy way is that we want to launch a new terminal. So when we are using Git to work with version control, we typically use this kind of environment. There are also other kind of plugins in different development environments that doesn't require this, but it's good to know that these kind of command line based things exist, and this is at least what I do and use a lot with Git, and I know that Dave does as well. So how do I take this repository from here to this computer in here? First of all, so this is now kind of a command prompt in your computer. So if you're working with Windows, you can open command prompt and do things in there. With ls command, I can actually list what is inside this folder that I'm now working on. pwd actually shows that, okay, I seem to be in this folder, home Jovian, who is the user of this computer. But from here I can see that in this folder where I'm now, there is a folder called work, there is installations.sh, and now I want to copy or clone this repository to this folder here. And how does that work? It's really simple thing. I said git clone, and that does the thing. Actually, before doing that, I might want to check that is Git installed in this computer. So git dash version shows the version of Git if it's installed there. If not, then you need to install that, but on all these computers you should have it. So then if I want to clone this repository, I just copy this address here, say git clone, and then with in this Jupyter Lab that is running on the browser, you should press Shift and right click, and then you have paste in here. So git clone and then the address to the repository on the web. So we can see that this is github.com Geo-Python 2018 exercise 1 and my username.git. So this is how we can do things and clone this. And now what it does is that it asks my username. So my username is H. Tenkonen. And then it asks my password for GitHub. And that I won't share with you, but I hopefully remember what it is. And when I type my password, and if it's correct, what it does is that it went to the GitHub, copied that whole folder into my computer, and when I see with ls, okay, now I have a folder called exercise 1 H Tenkonen in here. So as I mentioned, this is nothing more than a folder with files inside. And of course, when we take a look at this, what this folder actually has inside, it only has this readme.md file here. And that is what we saw in here. So that was the first step that you will do many times whenever you are working on the exercises. So you launch Jupyter Lab on the browser, you go to your own GitHub repository, copy the address of that one, clone it to this remote computer, and start working on the exercises. And then, of course, the other thing what you want to do is that you want to make some changes. So inside Distributor Lab, I now see that there is this exercise 1 folder in here, and what I can do is that I can actually use Distributor Lab to do some changes in here. So I have now this exercise 1 file, markdown file in here, and we can see that there are markdown texts inside this file. So let's do some changes and add some stuff at the bottom of this file and see what Git does when we do these things. So I basically write something and tell you about the story of my morning today. So let's see. Yeah, before I tell more about my life, so let's take a short period of time. So now I hope most of you who are interested has been able to clone the repository to this computing environment, and now I want to do some changes to the file. So indeed, what I will do next is that I have this README file in my exercise 1 repository, and there is existing text in here. And what I do now is that I will share some thoughts of my morning for you, and I add new text at the end of this readme.markdown file that we have here. So let's do something. I woke up at 7 a.m. feeling a bit tired of the last night, which went reading through the lesson materials for today. So now I have written some text in here, and basically what I want to do is that I want to save this, Control S, and now when I go back to the terminal, so of course you cannot see any things happening in here, but when we go to the terminal and we are still in the same folder, so I'm now with the pwd command, I can see that I am now located in this folder.
Can you quickly show how the
Yes, that is my plan. So some typical commands, so now I'm in this folder, so if I want to change the folder, these are really some basic things when working in the terminal. So if I, for example, want to go to the previous folder, so come back from this exercise 1 folder to the Jovian folder, so cd space ... is a command which takes me to the previous level up folder in the terminal. And ls was the command that I can actually see what kind of stuff is in this folder. So I have the exercise 1 folder, work installations.sh file. So if I want to go back to this exercise 1, so I just press cd, press few of the first letters of this exercise. So basically if I write, for example, exe and then press tabulator, so it will automatically fill in the rest because it knows that there is this kind of folder and there is no other file that can be starting with these same letters. So then you can just kind of automatically fill in the rest, which is a handy thing to know. And now I'm back in this README or in this repository of mine, and with git status, So this is now something that we use to check what has been done. Are there any changes in the repository that has been done in the files? And what we'll see here is that, okay, there is this readme.md, which is this file where I wrote this piece of text in here, and there is changes done in that file. So what Git does is that it exactly tracks what is happening inside those files. In addition to that, there is this kind of folder called ipimp checkpoints. You don't need to care about this. This is kind of internal version control, I think, of this Jupyter notebook system that we use here. But we are interested in the changes in this readme.md file. So with git status, it is possible to check what has been changed. So now what I want to do is that I want to save these changes. So basically I want to add this file first to the staging area. So if we go and see the materials, so now I have done some changes into this working directory to one of the files. So now what I do is that I add that file where those changes were done, and basically I use that readme.md and add that to the staging area. Then I want to take a snapshot of this time moment and commit those changes to the local repository, which is basically located on that computer that I'm working on now. And then I want to push those changes to the remote repository that is on GitHub. So this is what I will do next. So the first thing is that I want to add that readme.md file to the staging area. So git add and then the name of the file, so readme. And again, if I just write git add and re and press tabulator, I can just fill in the rest, which is useful. So git add readme.md, and when I press enter, nothing happens, or you cannot see any changes, but there has been changes happening. Now when I do git status and basically check where we are at the moment with this version control system, we have seen that this modified readme, the color changed to red. And this is kind of a color that indicates that these files are on the staging area, and these files are basically, you have chosen those ones to be added to the commit. So how do I actually take the snapshot of the history and track the changes is that I basically say that git commit, and then I say -m as message. So this is something that is really important and something really typical for doing commits and saving the changes of your repository, is that whenever you have done any changes, you need to add some kind of message to that commit that what was done, which helps you to track the history and the changes from the system later on. Of course, at this point, this doesn't seem anything like really useful, but it can be when you are working on larger projects. So now I can set that git commit, and the message could be, I shared, well, what could it be? Shared thoughts of my morning. Something like that. Typically you want to, please tell who you are. Oh yeah. So first what we need to do is that we need to say who we are. So we need to do some configuration. Because what Git does is that it tracks the changes that was done, but it also tracks who did those changes, and that is important. So we need to basically say to the Git system that who we are, and I said that my username equals to come on. H. Tenkanen, and then my user.email is, well, it doesn't need to be anything real. Like that. And now when I basically do the commit, so again, by pressing arrow up, you can go back to the earlier commands that you have been reading. So now when I do the git commit and message shared thoughts of my morning, it shows that one file changed. There was 4 insertions, so there was 4 lines added to this file. And now when we do git status, we can see that, well, there are some changes that have not been tracked, but those are something that we don't care about at this point. But now basically the history of this repository was tracked. So we have a snapshot, but now at this point it's still on this local computer. We cannot yet see the changes in this one if we, for example, refresh this page. So the next thing is, what I want to do is that I want to push those changes to this repository in here, and let's see how that can be done.
Before we move on, can I interrupt for just a second? So this git config username and user email, I mean, Hendrik has put in just some kind of empty things there, but normally when you do this, you do want to have your actual email address in there. It does possibly open up the chance that someone could find your email address and send you spam, but more importantly, if you do end up working on something where other people are making changes to the same code, they have a way to get in contact with you if there's something that they need to discuss, and there's no other venue than email. They have a real email address and a real name there to be able to look you up. The other thing here that's worth noting is this config thing is something, if you're using Binder or if you're using CSC notebooks, you will have to do this every time you create a new instance of a machine in Binder or in the CSC notebooks. If you're working on your own computer using Anaconda, you do this once and it's then stored in memory, so you wouldn't have to do this config step more than one time, unless you're using like the Binder or CSC, the cloud computers, where they have no way to know who the user is.
Yeah, this is now a bit kind of annoying thing in terms of using these cloud computers, as this is kind of unnecessary. Well, it's a necessary step, but you need to do it unnecessary often, because typically you indeed do it once and then you already forget about it, that you have some time done that. But yeah, it needs to be done. Those were good points. Let's start and see how we can push the changes to this remote repository after we have committed the changes into our system. So how we push the changes and save them into GitHub is basically with commit git push, and then you can specify origin master. And this is probably not always needed, but this basically says that we should push the changes to the master branch. We don't really need to know what branches are at this point, but this is basically those kind of comments that you should put in here. And when I execute git push origin master, what it does is that it again asks for my username. So I add my username here, and then it asks for the password. And as said, so now when I'm typing stuff, it doesn't look like anything comes in here, but they are actually going. And when I press enter, it will do the magic, send these changes to this GitHub repository. And now when I update the one, we can see that some meme did some changes. So interesting. That seems to be my name in there. But what happened was that there was now this added text down here. So I had a title, My Morning Today, and then the text that I wrote in here. So with a few comments, we were able to basically clone the repository, do some changes, commit the history of those changes, and then push back to this one. And now, for example, if I would go with this one to another computer, I could basically just pull those changes from here and do the stuff. What I do now, as Dave is stuck there, so I will now kind of act like another user who is doing changes in this repository. So I will, inside this GitHub repo, I can also do changes into this file. And basically there was this pencil figure here, which basically makes it possible to edit this exercise 1, and I write a message, hooray, and then I add some, well, I seem to be actually Dave inside here, and I said that minor edit, and then I do the commit and do the changes. So this is as basically typical steps what needs to be done. So I can really easily also, and you can do this as well, so you can really easily do changes also inside GitHub, and we can see that this message was done in here. But now when we go to Jupyter Lab and we check what is inside here, we do not of course see those changes because those changes happened now on the GitHub remote repository. So how do I actually get those changes that was now done by Dave into the same repository? So what I need to do is that I need to pull those. So git pull, and this is a command that I do inside that repository that I'm working on, and I again put my credentials here and enter, and now it showed that okay, I updated this repository and I updated this readme.md file, and there was something happening there. So 3 insertions, 1 deletion was done inside there. And now when I go and see this file, interesting. Readme. Why don't I see any changes? Typical demo effect.
Did you pull?
Yeah, I pulled. Fast forward. Exercise 1.
Does the editor need to be told to force to reread the file?
Let's try. Oh, okay. Yeah, so this is just some glitch with the system. So yeah, when I closed and reopened the file, now I saw that Dave/me did this change inside the file, and I can see the change. Indeed, it seems that Jupyter Lab inside this browser doesn't interactively update these contents here, so what you need to do is to close and reopen the file. It's a bit awkward, but seems to be that way. So this is really typical workflow when working with Git and GitHub. So you do changes, commit those, push those changes, pull changes, and so on. Are you doing some new stuff, or?
I can.
Yeah, or maybe that's not necessary. You already saw. So basically, the things that I did just before in GitHub repository, those changes could have been done by Dave on that computer, and he could have pushed those changes to the common repository where I would have pulled those changes. So that's a common workflow, and this is something that you will do a lot and often, so it will get familiar to you. And there is indeed all the materials available on the website, so you can read about all the steps that you need to do. Indeed, we use GitHub Classroom, so all the exercises are distributed in this way. You have seen this already, so we don't need to go that deep into that one. One maybe last thing about this good thing to know is that now, for example, in this repository, we can see that there are 3 contributors to this one. So there is me, then there is this Mehmet user who was the user for some reason from the Jupyter lab, and then there is Dave. And now we have the changes in here, and if we want to see the history, so what kind of commits have been done in this one, so we can press this history button in here, and here we can actually see all the changes that has been done into this file. So we can see that I did an initial commit, so I did the first version of this file 8 days ago. Then I added some exercise description also 8 days ago on the September 4th, and so on. And now from today we can see what was done in this one. And basically if we, for example, click this button here, we can actually see with these green lines that these 4 lines were added to this file. So it's really easy for you to actually see kind of what is the history of this specific file and what was done at what day, when, by whom, and so on. So it's really powerful tool to be able to do these kind of things, and especially when working on bigger softwares and pieces of code, it can be really useful to be able to do this. But that's it for the Git part. It might feel a bit confusing at this point, but I'm sure that it will become you will get used to it in time. Maybe we could at this point have a break before we continue with the Python stuff. So let's do this 10 minutes, okay.
Let's go for 15 minutes.
Let's go for 15 minutes. So 20 past 11, let's continue with the Python stuff and actually do some programming.